In this video, we'll be taking a look at how quicksort works. These type of sorts work by picking some pivot point and splitting the collection of elements into three different parts. One part that is less than the pivot, one that's equal to the pivot, and one that is greater than the pivot. Once split, the less than and greater than portions are typically then sorted. So quicksort works in a pretty much identical way here. There's a lot of different strategies for choosing the pivot point. Sometimes the pivot point is the last element in the collection, sometimes it's the first element in the collection, and sometimes it's the middle one. It just kind of depends on the implementation. Some of those which will result in a much more optimal quicksort, but I will leave the theory of that choice up for another discussion. For now, we'll just simply pick the first element in the section that we're actually sorting as our pivot point. Once the pivot point is chosen, we can then split our section we are sorting into three different segments, labeled L for less than the pivot, E for equal to the pivot, and G for greater than the pivot. After each segment is completed, we can then recursively sort L and G. So essentially, after each quicksort call, we're going to guarantee that the pivot or segment E is in sorted order. So we're just going to keep on repeating that quicksort in this manner until everything has been sorted. So how do we organize the portion being sorted into three segments that we actually need? Well, we actually need to start out with 4 segments instead of just our original 3. So L, E, and G, so less than, equal to, and greater than the pivot, will initially all be empty. But we'll now also watch segment U, which is the elements that we haven't actually looked at yet. So the stuff that we haven't moved into any of the segments. To work with segmenting out our portion, we need to also maintain 3 indices. So for the less than segment, we're going to watch the index that immediately follows that segment. So the element immediately after. Then the other 2 indices, one for preceding segment E, so we'll watch the element right before segment E, and then we'll also watch the segment right before segment G. But let's take a look at how this gets set up initially for a simple list. So I'm just going to draw a very basic list of numbers here. So let's do 2, 4, 3, 1, 2, 3, 4, 5. So let's just do 7 numbers here. And so we have something that looks like this. Let's label where all of our segments actually are. So remember, segment L is going to be elements that are less than the pivot. And our segment L, for the index for our segment L, is going to be the location following segment L. And so typically, right, the less than portion is going to be on the left, greater than is going to be on the right. So segment L, since we haven't actually sorted anything, segment L is actually going to point to here, right? Because this portion over here is actually going to be L, right? L has nothing in it so far. So L, the location following segment L. So following segment L, right? Then we are going to have the location preceding segment E and preceding segment G. And now in our algorithm, it's going to actually be really a lot easier if we keep E and G initially to be at the same location. So if the greater than is going to be on the right-hand side, that means our greater than portion is going to be over here on the outside bounds of our array. So that means G is actually going to be here. So the location preceding segment G. So G is actually over here on the right-hand side. So this is preceding G. Right? And that means E is also there. So E and G are going to be at the end of our array, and L is going to be at the beginning of our array for those particular indexes. Right? So let's then take a look at how we actually get all of these segments moved into our specified locations. Once we have our pivot point and the indices for each segment, we can then process all of the unknown elements. So the elements that we haven't actually moved into our segments yet. And so we're going to start at the end of U. So we're going to start at the end of our array and then work our way backwards. So if it is less than the pivot, so if the element that we're looking at is less than the pivot, we're going to swap it with the element following segment L and increase L's index. And remember that index keeps track of the element immediately following L, the segment L. And so if it, so then we essentially grow that segment by 1 when we swap something into right after it. If that element that we're looking at is equal to the pivot, we just need to decrement that index, the index that tracks the element before E, because that's the element that we're essentially looking at the moment. And so we just decrement 1, and that increases segment E. Otherwise, that element is bigger than the pivot, and so we need to swap it with the element right before G. And so we need to then decrement the index of both G and E in that case, because segment G is at the end, and then segment E is right before it. And so if G grows by 1, we need to shift segment G down by 1 as well. And so remember, those are G and E, right? Those are both tracking the element right before their respective segments. But after this is completed, we have correctly created a less than, equal to, and greater than segment that we can then recursively sort for the less than segment and the greater than portions, because the equal to portion has been already sorted or is already in sorted order. But let's take a look at how we can sort our previous list here. So I'm going to modify this slightly just so we can have all different cases. So specifically cases where it's less than, greater than, and equal to the pivot. And so let's take out some of that. Let's make 1 here. Let's make that equal to 4. So what we're going to do here then is keep track of the index immediately following segment L. We're going to track the segment that is equal to the pivot. And we're also going to track the segment that is, let's do blue here. We're also going to track the segment that is greater than the pivot. This is U initially, right? Because we haven't looked at anything yet. And L is over here off in no man's land, and same thing for E and G, because there's nothing in those segments yet. So let's start looking at our elements. And so our algorithm here, we're going to look at the last element of segment U. So if this segment, or if this element is less than our pivot point here, we're just going to choose as the first element in our segment U. And so that means our pivot point initially is going to be 2. So is 9 bigger than or greater than the pivot? So that means 9 is bigger than. So we're going to go to our otherwise case. So it says swap the last element of segment U with the element preceding segment G. So that is the element that we're on. So we're just essentially swapping it with itself. And so 9 stays where it's at, but we do move segment E and G. So E and G are no longer here. So E still has no elements, right? But 9 is now in segment G. Okay. We'll loop back up, right? Look at 7. 7 greater than or less than our pivot. Well, 7 is greater than our pivot point. So 7 gets swapped with the element preceding segment G, which is here again, right? And so gets swapped with itself, stays where it's at. And so G and E get moved here. So G and E. And so we are basically increasing our segment here. So let's actually just leave it there. So 7 and 9 are now in segment G. Let's get 5. 5 greater than or less than 2. Well, that happens to be greater than. So again, same pattern. We're shifting E and G down. So G and E. And then G gets grown. 4 greater than less than pivot, greater than again. So we can shift that down. Now, and again, right, every time our U gets decreased, right, our U is slowly kind of working its way back backwards through our unknown segment. Now, just to kind of skip ahead just a little bit, we can kind of guess that, right, everything here is less than the pivot. So I'm going to kind of fast forward here to this point here, where G and E are here. Now, our segments, right, we're back to the pivot point. Right? And since our less than segment and our equal to segment and our basically all of our segments here are empty now, right? We have our segment U is empty now because we have nothing left to actually look at because we've already looked at 2, right? And since E and G, or since basically E and L are now at the same position, that means we have nothing left to actually observe. And so we can go on to the next iteration of our quicksort. Okay. So this was our iteration number 1. Right? So we can then go on to a second one. So let's copy this here. So our pivot in this case is going to be what? Well, we know 2 is in sorted order, right? So our segment that we're actually concerned about here is this right here, right? So this is the segment that we're actually sorting. We need to sort the less than segment, so quick sort on the less than side and quick sort on the greater than side. But since the less than side has no elements in it, we don't need to, that just ends up returning because there's nothing there. So we're going to do quick sort on the greater than side. And so now our pivot is going to be 4. Okay. And again, we need to track our less than segment, then our greater than segment, and our equal to segment. So is so 9 greater than or less than the pivot. So we're going to shift this over, and I will kind of fast forward just a little bit because we know 9 is greater than our pivot, 7 is greater than our pivot, and so is 5. And so we are basically fast tracking towards this spot here where we have G and E. Okay? Now, this is a new case that we haven't done yet, where we have the element, last segment of U. So U is now here, right? So last element of segment U is equal to the pivot. And so all we're going to do is decrement the location preceding segment E. And so E has nothing left in it. And so that's where this is here. And so all we're going to do here is move E to this location. And so now we have two things, right? Now E is here. Right? E is now has started to separate away from G. And so that actually makes this 4 now part of segment E. And so now we also decrease U, or our segment U is now looking at 4 and 3. So 4 and 3 here. So 3 less than the pivot. This is one that we haven't done yet either. So this is the last element of segment U. So now we're going to swap it, since it's less than the pivot, we're going to swap it with the element following segment L, and then increase the location following segment L. So we're going to swap 3 with 4. So 3 and 4 get swapped. And then L gets incremented. So now L and E are pointing at the same thing. Okay? And so that means 3 is our less than segment, and 5, 7, 9 are our greater than segment, and that leaves with 4 and 4 being our equal to segment. And so essentially what we have here is our pivot points are in sorted order. We have our less than segment on the left-hand side and our greater than segment on the right-hand side. Now, we will still call quicksort on 3 because it is a segment, but since it only has one element, quicksort won't actually go into the iteration. It's just going to say, well, the segment's only one element long, so there's no point in actually trying to sort it because it's already in sorted order. So what we'll actually end up doing, so that would be number 3. That's our less than segment there. But since that one is already in sorted order, I'm not going to actually walk through that. But I will walk through again the greater than segment since it has more than one element. And so we need to move this. So this is number 4 here. And the segment that we're actually sorting is these here. Now, 5, 7, 9 are in sorted order, but we don't know that yet, right? Because we haven't actually looked at them. They're unknown segments or unknown elements. So we still need to go through this process of finding segment L, or the location immediately following segment L. Then we need our segment E and our segment G, which are all both here at the end. Our pivot point in this case, we're just going to stick with picking the first element in our segment. And so that would be 5. Now, with segment 5, we're going to look at everything over here on the right. And so we will see that 9 is greater than our pivot. So 9 is greater than our pivot. And also 7 is greater than our pivot. And so then G ends up here, and so does E. And so when L and E are equal to, we know our loop is finished. And since we have no less than segment, 5 is we won't call on our less than segment since that doesn't exist really. 5, there's no segments there. 5 is in sorted order because that was our pivot point. And so then we would call our quicksort again on our greater than segment. And I am simplifying this in some sense because I am not going through the process of what quicksort does on segments that are 1 or fewer. But essentially, we're not going to go through the whole quicksort process with them. We don't actually have to try to sort elements like that because the segment is already sorted. But in this case, we are concerned with this segment here, 7 and 9. So there may be some intermediate steps between here, right? Because there's still a segment, but they're segment of 0 or 1. But we will actually do a full quicksort on 7 and 9. So we still need to select our L. We need to assign our G index and our E index. Our pivot point in this case is 7. And so we will find that 9 here is greater than our pivot point. And so E and G get shifted over. So that means 9 is part of our greater than portion. E is here. So our loop stops. G is there as well. Now, quicksort again would still be called here again on the less than portion and the greater than portion. But each one is already, there's not more than one element in each portion. And so we end up getting in sorted order. So that's pretty much it. This was a full quicksort example starting from the beginning, starting from scratch, where we pick our pivot. So in this case, in our lab, we're going to pick the first element in our unsorted portion. And then I went through each of the different cases, what happens if the element that you're comparing is less than, greater than, or equal to our pivot point, and how those segments actually get created. But this is going to be your goal to complete during lab this time. So now that you've seen an actual example of how quicksort works, let's take a look at the complexity of it here. So in the worst case scenario, quicksort is not actually that quick. It's actually just as bad as bubble sort in the worst case at big O of n squared. Now, not only that, but it can be quite expensive in terms of recursion, which can cause Stack Overflow issues, especially for very large data sets. So quicksort is also not very stable, but that doesn't impact the use of it much unless you're not sorting value types. If you're sorting custom objects that require multi-key comparison, things like that, quicksort has to be modified to be more stable. Overall, though, we can actually optimize our quicksort to be pretty good for your average case. And so if we choose a pivot point that actually causes the collection to be segmented more efficiently, so such that our segments are mostly in equal size, quicksort is actually very good and is actually pretty quick. So in our next lab, when we create our hybrid sorting algorithm, quicksort will be used again, but be supplemented with some of the other sorts that we've covered already.